Today I will talk about simulation. This is part of my series of lectures on simulation techniques, and this is under business analytics. This is my lecture outline. First I will give introduction, then I'll talk about modeling, then I'll describe simulation steps, then I'll talk about types of simulation, and finally a little bit in detail application of simulation techniques. The goal of the data analytics is to create a simplified model to determine the behavior of complex systems. Simulation models imitate physical systems in a virtual environment and retrieve useful output statistics from it. A model should have the design characteristics of reality in order to produce the essence of an actual operations. Simulation is a cost-effective method for evaluating the performance of resource allocation and alternative operating policies. Simulation is one of the predictive analytical method. It is not an optimization technique. It helps in data-driven decision making. Now, simulation involving time variable may be either continuous time or discrete time. Discrete time may be either equal time stamps and unequal time stamps, that is jumping of time. We will see more in detail about discrete event time in discrete event simulation technique. Objective of simulation is modeling a stochastic system with a goal of predicting system behaviors. As we have seen, a model is nothing but variables and their interaction. Simulation models may be mathematical models and process models. So a model is a formal description of the process or approximate representation of the process and mathematical and computational methods to find the best course of action. So this is a model. Modeling may be predictive modeling or explanatory modeling. In predictive modeling, we want to predict how a process behaves under given condition. In explanatory modeling, we want to just understand the system and to relate a logical structure to sufficiently explain a behavior. Complexity in modeling include three aspects. One is chaotic nature of system. Second is criticality. Criticality is usually regional or local, and it is self-organized criticality. Emergence is one of the important phenomena, and one of the simulation technique, that is agent-based modeling, involve emergence. So even in a homogeneous system consisting of many identical parts, interaction between components can lead to the emergence of a structure or pattern. Then what are the steps of simulation? First of all, we define the problem. Then we state the objective. Then we construct an appropriate model. Then we do experimentation with the model. For example, what if scenarios, stress test, and defining strategies. Then we evaluate the results of the simulation. In mathematical terms, we observe input data, and for simulation, input data types can be divided into deterministic and probabilistic. Or another type of classification is discrete and continuous. Then we fit the data to theoretical distribution if input is probabilistic, and the distributions which are used include discrete distributions like Bernoulli's distribution, Poisson distribution, and geometric distribution, continuous distributions like uniform distribution, exponential distribution, triangular distribution, normal distribution, Weibull distribution, gamma distribution, and beta distribution. Then we generate data to derive simulation. And types of simulation. There are four types of simulation: Monte Carlo method, agent-based modeling, discrete event simulation, system dynamic modeling. Monte Carlo simulation is a probabilistic simulation. Monte Carlo simulation is not very efficient, and it is the basis of Bayesian analysis, and there are numerous applications of Monte Carlo simulation. Agent-based modeling. Makes a move in agent-based modeling, and this is known as emergent behavior because interaction of all the agents produce a emergence pattern. The emergent behavior takes place in reaction to a discrete set of rules. Disadvantage of agent-based modeling is that an outage or similar disruption between a small number of agents can propagate quickly. Then discrete event simulation. Here, time is broken up into distinct steps rather than being continuous, and it is used widely in manufacturing, logistics, and operations management. System dynamic modeling is used in population, pandemic, and economic problems. I will describe in detail all these four methods in my next four lectures. Then applications of simulation. Applications in operations management include applications in production planning, Monte Carlo, production scheduling, Monte Carlo, capacity planning, Monte Carlo, and discrete event simulation, bottleneck analysis, resource allocation, inventory planning, storage management, operations planning, modeling of just-in-time and lean management, model of capacity and demand, agent-based modeling. Application in supply chain management and logistics, supply chain design, transport planning, storage management, inventory planning, warehouse operations, policy evaluation, risk assessment, supply chain optimization. Then in marketing, marketing campaign simulation, Monte Carlo, profit and sales prediction, diffusion of information and innovation using agent-based modeling, interfirm relationship, strategy, and competition using agent-based modeling, marketing mix models and marketing promotion, consumer behavior, social network, new product adoption model. Then in retail, sales automation, inventory management, finding an optimal price point for a product, retail location decision, retail and service escape design, and retail store design. Then customer relationship management, queuing model for customer service and other CRM activities. Then in finance management, portfolio evaluation and optimization, portfolio management, valuation of equity options, likelihood that an asset price will move in a certain way, sensitivity analysis in financial modeling, default risk in financial analysis, threat modeling, capital investment decisions. Then in healthcare, healthcare system operations, including staff and patient scheduling, resource allocation, capacity planning and management, health economic evaluation, system diagnostics, and effect of operations changes. All these using discrete event simulation. Then disease progression model in an individual, disease screening model, health behavior modeling, what if analysis in pandemic, using system dynamic modeling. The options include either do nothing or effective quarantine or additional testing or containment. Then spread of epidemics, human immune system understanding, drug development, stochastic gene expression model. Then other uses, miscellaneous uses include self-driven cars. We can use ABM model because cars can have senses, memory, and they work under rules. Then population dynamics, threat of biowarfare, plant-animal interaction, organizational behavior, team working, traffic congestion, understanding the economy from bottom up, modeling of economic collapse. Then climate solution simulation using system dynamic modeling. The options include electrifying transport, splicing the carbon, activities improve agriculture, and the effects are seen on temperature, air quality, and sea level. Then water resource management, future supply and distribution of skilled manpower, instability of worker employment in a particular firm, growth and decline of a company. Then probability of cost overruns in large projects, project management, network performance in telecommunication, network simulation using discrete event simulation, then measuring risk in insurance business. So these are the uses or applications of simulation techniques. Thank you very much.